Alright, this is the physics of dunking. Damn, that shit was hard. So we throwing alley-oops. Alright, we throwing a bad one at 0 degrees angle. This is what it looks like.
Go.
Alright, so now we're throwing at a 90-degree angle.
Go.
Right, so now,
look at him.
Alright, so now we're throwing a perfect alley-oop at 45-degree angle.
So, as you clearly saw, there's different angles at which you can throw an alley-oop. And here to explain that is my boy, Ryan Phillips.
Alright, so when you're throwing an alley-oop, you want to throw the perfect alley-oop. And to throw the perfect alley-oop, you have to throw it at the optimum angle. As you saw in our videos, throwing the ball at a 0-degree angle does not work. Throwing the ball at a 90-degree angle clearly doesn't work either. Unless you do. No, I'm just playing. Just playing. But throwing the optimum angle at a 45-degree angle. Throwing the ball at an optimum angle at 45 degrees. Right? That's perfect. Perfect for height and distance. And that's why the perfect alley-oop works. Because it goes like this and travels to the basket, and we got a dunk. Dunk fest all day. Bang. We're done. Alright, so this your boy Ryan, your boy Rad. Dtay's the cameraman. Alright, so we're here to talk to you about the physics of dunking, and to explain that, my boy Rad.
Alright, physics of dunking. Pretty simple. Newton's third law, which states for every action there's an equal and opposite reaction. So when the athlete applies a force to the ground, taking his last step, the ground reacts back on him with an equal and opposite reaction, propelling him upwards. And after that, it's bang time. Many athletes, there's a myth of hang time. Michael Jordan, they said he could, he had hang time. That's a myth. Michael Jordan, he could apply such a great force to the ground, and the ground would apply such a great force back to him, that when people would jump with him, he would still be going upwards as they were at that peak jump, which made it seem like, projected an illusion that he was defying gravity. But that's a myth. So basically, in order to jump higher, you need to be able to produce a greater muscular force, because when you can do that, the ground can apply a great force back to you, propelling you upwards. So basically, what does this mean that me and Ryan were able to do those dunks? It means that we're jacked. But Superman.
Alright, this is the physics of dunking.
Go.
Hey, yo.
Go.
Ready? Alright. I don't know what I'm about to say.
Go.
Alright, so we throwing alley-oops. We're gonna throw a bad alley-oop. This is at 0 degree angle. Now we're throwing at a 45 degree angle. Perfect alley-oop pass. Alright, so now we're throwing the perfect alley-oop at a 45 degree angle.
Go.
Alright, so now we're gonna throw the perfect alley-oop at the 45 degree angle.
Go.
Alright, so we're throwing the perfect alley-oop, throwing that 45 degree angle.
Alright, go ahead.
Newton's third law in action.
Go ahead. Go ahead.
Shameful.
The universe likes to interact. You can't touch it without it touching you back. The universe likes to interact. You can't touch it without it touching you back. So do unto others as you want them to do to you. You can't touch them without them touching you back. Newton was no fool. His third law is a golden rule. To every force and action, there is an equal and opposite reaction. To every force and action, there is an equal and opposite reaction. To every force and action, there is an equal and opposite reaction. To every force and action, there is an equal and opposite reaction. Bat hits ball, ball hits bat. Boxer whaps bag, bag whaps boxer back. Hand pushes on wall, wall pushes on hand. Man pulls on spring, spring pulls on man. Earth pulls on rock, rock pulls earth back. Rocket pushes gas, gas pushes rocket back. Head bumps ball, ball bumps head. Car hits bug, bug hits car, bug is dead. To every force and action, there is an equal and opposite reaction.